All right, so a wonderful good morning, everyone. So this is Hampel Kliman, your tutor and your mentor, and this morning I bring you a tutorial on projectile motion. So to those of you that are following me on YouTube, and if it is your first time, make sure that you subscribe so that you'll be able to receive every video notification that I'll be able to upload. So those of you that are following by now, you know that in physics I have been doing kinematics, and today we'll be doing kinematics, that is motion in 2 dimensions. So projectile motions are very simple. It's a very simple topic. It will only take you to practice them all, and you also have to understand that the formulas that we use under projectile motions must not be memorized, but instead they must be known. You must know how to come up with those formulas. So now, under projectile motion, this is just motion in 2 dimensions. Okay, projectile motion is simply motion in 2 dimensions. What do we mean when we say motion in 2 dimensions? For example, if let's say this is 0 meters per second, okay? Then we have a person at this position, then this person happens to throw a stone. Then we expect this stone to simply take this motion. So at every particular period of time, you discover that you are going to have something. You can have something like this. This is also going to be a motion of a stone. Motion of a stone like this. At the same time, you also have something like this. Okay? Then you have something like this. So this is the motion of the stone. At this point, you're going to also have something like this. So you may have some angle theta here, right? You also have some angle theta here. Then this is y. So you discover that this is vy, or the component of the velocity in the y. Then this is going to be vx, or the component of velocity in the x. But then when you reach at this point, you discover that you only have one component, and that component is simply the vx. Therefore, you discover that at this point you don't have any vy component. But when you reach here, the motion continues. You're going to have something like this with an angle. This is your vy, this is your vx. So you discover that this is the motion that a stone is going to take. But then from its initial position, we can also have this velocity, this motion, okay, the velocity like this in this motion. Then we can also have an angle theta of this kind. Okay, this is the main angle theta like this. You have that angle theta. The angle theta may be equal to anything. It may equal 90, it may equal 150, it may equal anything. Okay. Now, if this is the motion of the stone, then automatically we know that, remember when I was teaching vectors, we can label this one as the velocity v. Okay? Then, if we want to find the component of this resultant vector velocity v, then automatically we know that in the x, we are going to have vx equal to this resultant vector of velocity multiplied by cosine theta, like this. The same thing in the y. In the y, it's going to be vy equal to this velocity sine theta, where theta is simply this angle. Now, in order for us to make everything simple under projectile motion, we take the motion of the stone into two different individual dimensions, or we are going to solve them independently, where we take the motion in the x alone, we also take the motion in the y alone. Then everything is going to be very easy for us. Okay, now let's discuss motion in the x. Now, for motion in the x, the first thing you have to know is simply the formula for the velocity x component in the x-axis. I think I've outlined it. It's here. So we know that Vx is equal to V cosine the angle theta, like this. Okay, that's the formula. That's the formula that we use for us to find the velocity in the velocity as x component. Yes. Now, you must be able to know that, suppose this is a stone that is moving in this direction. It's moving in this direction. You discover that it is covering some distance, which happens to be this one, in the x. This distance in the x. Now, one thing that you must be able to know is that the acceleration in the x-axis is simply 0, because there is no acceleration in here. Therefore, we can say that the acceleration in the x is equal to 0 meters per second. Okay, 0 meters per second. Now, we know that, like I said, this stone is covering this distance from 0 meters per second up to here. You discover that the distance covered in the x is this one. Now, this distance from here, up to here, this distance is simply what we're calling as the range. The distance is called the range. This is the range. Now, how do you calculate the distance covered from here up to here? We know that x is equal to Vxt plus 1 over 2 at squared, like this. X is equal to Vxt plus 1 over 2. Now we say that in the x, the velocity, the acceleration is simply 0. So I can put my 0 here. Then everything is going to become 0 here. Therefore, x is going to equal Vx multiplied by t, like this. Now, this formula is what you use to find the range. Therefore, you can say that the range is going to equal Vxt. That's the formula for the range, okay? The range, which happens to be this distance from here up to here. This is the formula. Now, you only use this formula when you have been given the time and the velocity component in the x, which happens to be this one, okay? But then, suppose you have been given Vx, you have also been given the range. You can find the time by simply saying Vx t is equal to range, which happens to be x. Then you can simply say over Vx over Vx. The time can simply find the time that it took for it to move from here up to there. Okay, suppose you have been given this. But then, how about if, for example, you have not been given this component, okay? You have not been given the Vx component in the question. What do you do? How do you find the range? So we know that range is given by Vx multiplied by t. Therefore, we can simply say range is equal to, now this Vx here, remember that it is equal to this. So you can replace this Vx with V cosine theta t. Okay? V cosine theta t. That is how you are able to find the range. Now, you can use this formula when you have been given the V, which is the velocity, which happens to be this one, this main velocity. When you have been given this main velocity in the question, then automatically you can use this formula to find the distance from here to here. If you want to find the time, automatically we know that range, so this is the formula also, this formula for finding the range. You can name it as formula 2 if you want. It's very simple, I've just done some algebra there. Then we can simply say that the range is equal to V cosine theta t over V cosine theta over V cosine theta. So we can say t is equal to the range, if you have been given, over V cosine theta. So you can find the time that it takes, time it will take for it to move from here to here using this particular motion here. All right, so this is just everything that you have to know about motion in the X. There's nothing more about that because there's no acceleration mainly in the X axis. Let's get it to the Y. Let's now take it to the Y axis. Let's see the type of motion that's there. All right. Okay, so let me just do this. Just exchange everything so that you'll be able to see clearly. Here, I need the diagram to assess my work. All right, so for motion in the Y, if you want to find the Vy or the velocity component in the y-axis, already we know that the formula of use is simply Vy equal to the main velocity component, then sine theta, like this. Okay, sine theta, like that. It's quite easy. Now, remember how the motion of this particle was moving. This thing was moving in this direction like this, but then when it reaches at some point, this point, you discover that there is going to be some force that is going to act such that it wants to bring this particle to its initial position. So there is going to be a force which we're calling as the force of gravity in the negative direction to be putting it down there. Therefore, we say that the acceleration that exists in the y-axis, the acceleration is simply called the acceleration due to gravity, which happens to be negative. Okay, get to the same diagram. Now you are going to discover that as this thing is moving in this direction, it is going to reach at some point at some point, which happens to be this point, where you would discover that at this point there is no y component. Okay, there is no velocity, there is no vy. Okay, there is no component of velocity in the y. Therefore, at the maximum position, which happens to be this one, maximum position, the velocity in the y is equal to 0 meters per second. That is maximum point. Now, we know that if this is the maximum point, then automatically from here, this is the height. Okay, so this is going to happen to be our height up to this point. This is the height. Okay, so now from here, what else are we supposed to know? How about if the body moves from here and then it reaches at this point? At this point, what happens to be the acceleration here? It is just the same as in the x. At this point, which happens to be the initial point, the acceleration, okay, we can say at final point, acceleration in the y is equal to 0 meters per second squared. Okay, at this point, the acceleration in the y is simply 0 meters per second. 0 meters per second. All right, let's get to do some other things. Now, how about if you have been asked to find the total time of flight from this point up to this point? What could be the total time? You'll be asked that question. How do you find the total time? It's quite simple. So we know that S is equal to Vyt minus 1/2 gt squared. Now, why put a minus? Because this g is negative, remember? It's negative in the y. So from here, this is 0, because that is where we're starting from. Okay, then we are going to say Vyt, where Vy is a component of the velocity in the y, then over 2, then gt squared. We want to find the total time of flight, so we can say over t, we'll get a 0 here, equal to, this is going to be Vy minus, this is going to be 1/2 gt. We can take this side, so it's going to be 1/2 gt equal to Vy. Then from here, we can cross multiply. If we cross multiply, you discover that we're going to have gt equal to 2Vy over g. If you cancel this side, discover that t is going to equal 2Vy over g. Therefore, total time of flight is going to be 2Vy over g, like this. Okay, so we can say total time of flight, like this, total time of flight. But then you can change this also, because you know that this Vy, because Vy is simply 2 open bracket V sine the angle theta over g. So this is how you find the total time of flight. Okay, total time of flight. The time it took for this guy to move from here up to here until it reaches at this point. This is the time that it took. If you are asked to find the time that it took for it to reach the maximum height, automatically you just divide whatever you find here by 2. Then automatically you'll be able to find the total time that it took for it to reach the maximum height. You divide this by 2, then you find the time it would take for it to reach the maximum height. But for the total time, automatically you just use this formula which has been given to you here. Okay, so total time of flight is here. How about if you want to find the maximum height? You want to find the maximum height, which happens to be this one. If you want to find the maximum height, this is also simple, because we know that v squared is equal to vy squared plus 2a x. But then we're not dealing with the x, we're dealing with the y. So we just put a y here, like this. Okay? Or let me say, let's put h for maximum height. Okay? But then we know that from here, it will be v squared equal to v squared y. We are going to put a minus here because this acceleration is simply g, and g is negative in the y. So it's going to be 2g, then it's going to be h like this. It's going to be h like this. Then from here, we know that this is going to be a 0. This is 0, okay? This is 0 because this is where we're starting from. So I have 0 equal to v squared y minus 2gh. So we can take this guy this side. It will be 2gh equal to v squared y, which happens to be a component in the y. From here we can say over 2g over 2g. From here the maximum height is going to be v squared y over 2g. Okay, like this. But then remember that the maximum height, remember that this is a component. So this is just the same as v sine theta squared over 2g, like this. Okay, 2g. Then from here, this can also be written as h is equal to v squared sine to the power 2 theta over 2g. Okay, over 2g. So this is how you find the maximum height. This is how you find the maximum height. So this is everything that you are supposed to know about projectile motions. They are very simple to understand. You just have to know how to deal with the formulas given in particular. Okay, so a rewind of everything. So this is the range from here to here. This is the range from here to here. You can find the total time of flight, which we found to be here. Then if you want to find the maximum height from here to here, the maximum height, the formula given is this one, where this v is simply the velocity given, which happens to be this one, sine 2 to the power 2 theta over 2g, where g is simply the gravitational field force, or the acceleration due to gravity. Okay, so this is very simple. If you have a question you want to ask, you can inbox on this WhatsApp line and I'll be able to respond to you in my time. So I'm sure you have enjoyed. Don't forget to subscribe and also hit the like button. Thank you so much. Thank you. I think this is where we'll end our lesson. The next time we come, we'll be solving some questions, some practice questions. So don't also forget to mention in the comment system if this video has really helped you. Okay, so thank you so much.